This is the Morning Boot daily tech news with the root access. Built for IT leaders, cloud engineers, security professionals, founders, and tech-curious listeners who want context, not hype. We cover what's happening in AI, cloud, security, and enterprise tech, and what it means for people running real systems. No fluff, just what shapes how we build, operate, secure, and scale. It's February 6th, 2026, around 9:18 in California. Let's start with what matters. What if AI could split up work the way your dev team does during sprint planning? Anthropic just released Opus 4.6 with something called agent teams, basically groups of AI agents that break down big tasks into smaller chunks and tackle them in parallel, just like humans do when coordinating a project. They've also packed in a 1 million token context window. To put that in perspective, that's enough to process entire code bases, thick compliance documents, or massive research archives in a single pass. Here's what caught me off guard. The idea of AI agents explicitly coordinating subtasks mirrors how engineering teams divide and conquer work. It's not just about raw power, it's about orchestration and collaboration. For IT teams managing document-heavy workflows like compliance audits, legal reviews, or research synthesis, this could mean faster turnaround without sacrificing accuracy. Think about how long it takes to parse hundreds of pages of technical documentation or regulatory filings today. Agent teams could slash that time dramatically. Practical. Here's a practical move. Experiment with segmented AI workflows versus single-agent processes in your environment. Measure not just speed gains but coordination overhead. How much does it cost to manage multiple agents versus one? Set up a pilot with something like contract analysis or log review and track efficiency and error rates. The goal is understanding where parallel processing adds real value and where it introduces complexity. You don't need. Moving on. OpenAI just launched Frontier, and it's positioning AI agents not as isolated tools, but as coworkers who collaborate with you and each other. Frontier simplifies connecting diverse data sources, so agents can execute complex tasks in real time across different systems. It's designed to blend outputs from multiple AI labs and platforms, yours, theirs, whoever's. The counterintuitive part? AI agents designed as team players rather than standalone solutions might actually smooth enterprise adoption. Instead of wrestling with siloed models, you get a framework where agents coordinate across boundaries. For IT leaders and cloud engineers, this matters because it suggests a shift from single-vendor lock-in to hybrid AI ecosystems. You could run proprietary models alongside third-party agents and orchestrate them through Frontier. Integrate Frontier agents into one existing business process, maybe customer support triage or incident response workflows, and measure improvements in human-AI collaboration and data unification. Pay attention to how easily agents pull from disparate sources and whether coordination overhead offsets efficiency gains. The insight here is whether multi-agent orchestration simplifies or complicates your stack. Let's shift gears. Elon Musk just merged SpaceX and xAI in a deal worth over $1 trillion, and it's a bet on something most wouldn't touch: converging AI with space exploration at massive scale. This isn't incremental innovation. It's a wager on unproven AI space applications deployed rapidly in one of the most hardware-intensive, risky industries out there. SpaceX confirmed plans to go public this summer, which adds another layer of complexity and scrutiny. Here's what's wild. Space exploration has long been dominated by traditional aerospace engineering and slow, methodical advances. Musk's betting that AI integration, autonomous spacecraft, AI-driven mission planning, predictive maintenance can leapfrog decades of incremental progress. For IT and tech decision-makers, this highlights cross-domain innovation risks and opportunities. When verticals converge, new capabilities emerge, but so do new failure modes. Practically, watch how AI reshapes mission-critical systems in environments with zero margin for error. The lessons from AI in space: high-stakes decision-making, autonomous operations, real-time problem-solving, translate directly to enterprise IT running critical infrastructure. A useful reflection is identifying where AI-driven autonomy in your systems could accelerate progress or introduce risk, and stress-testing those assumptions before deployment. And finally, China sold nearly 90% of all humanoid robots globally last year, and that's not a typo. In a sector many assume is led by the US or Japan, China's locked in a commanding early position through deliberate state policies, public investment, a mature supply chain, and rapid AI hardware and software advances.
The global humanoid robot market is projected to hit $38 billion by 2035, and China's early lead could make it hard for competitors to catch up. The strategic insight is straightforward but often overlooked. Government-backed ecosystems can effectively lock in market leadership in emergent AI robotics sectors before others even get started. For cloud engineers, robotics teams, and supply chain leaders, this signals an urgent need to focus on supply chain resilience and AI hardware co-design. If your robotics or automation strategy relies on global supply chains, understand where dependencies lie and what alternatives exist. A practical experiment is benchmarking Chinese humanoid robotics platforms against ecosystems from other regions. Evaluate distinct capabilities, integration challenges, and cost structures. The goal isn't just competitive analysis, it's understanding where innovation is concentrated and how to navigate partnerships or build alternatives if geopolitical risks materialize. That's it for today's Morning Boot. Thanks for listening.